Hello, 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 hello.
जी सर, आवाज आ रही है।
Assalamu alaikum.
वालेकुम
And
सलाम।
good evening to everyone. Morning, evening, night. So there are so many people from different countries joined here. You just wait for the next 13 minutes and then we'll start at 4:30. Okay.
Okay, sir.
So you'll have to bear with me. Okay. So a little bit of training rules. First, I'd like you all to rename yourself as your first name and the country so that I know that who am I communicating with. The second thing is that you'll have to keep your microphones muted at all times. If there are any questions, you can mention in the chat. I will look at the chat after one training set is complete and then any of your questions, so I can answer those questions, okay? And this is, like I mentioned, a very basic level training. So we will proceed very slowly so that even the very fresh engineers who don't have any understanding of what PS4 is, they get a hang of what PS4 is. And then when further training session, we will go towards advanced topics and all that, okay? And as this training session is free, so what I want every one of you for a commitment is that whatever you learn in this training session, it should be you should consider it your responsibility to pass it on to at least one student who doesn't know about PS4, so that what I intend is that the next 6 to 9 months, we have many PS4 engineers available who can handle the PS4 in different operators, different countries and all that, okay? Okay, so coming forward, okay, so this is the basic network architecture of PS4, okay? So as you remember, first we had 2G, then we evolved to 3G, then we evolved to 4G, and currently in many countries we have 5G as well. So we'll just talk about the network architecture in 2G, 3G, 4G. 5G is a little bit complicated, so we will cover that in the advanced training session as well, okay? So if you look at the architecture, if you can check my screen, so in 2G, you have a BTS. BTS is the base radio technology. So you have different, okay, Nasir. Yes, Nasir? You raised your hand. You can mention, you can type your query. No? Okay, let me just, I think this is, so let me just give you the permission to. Okay, so I've given you the permission to unmute yourself. So, okay, if you have a question, you can ask. That is going to be easier. Right, so we'll be discussing in 2G, the basic radio network element is called BTS, based on serial system, which is then connected to your BSC, okay? Those of you who are part of radio team, they must know that the BSC has a component called the PCU, which basically connects with your packet core entity, the SDSN, okay? So the main nodes in our packet core network architecture are SDSN. You have GGSN, which is then broken down into SDW and PGW. You have Pcrf. We have DNS. I'll show it in the later slides. We have border gateway. We have charging gateway. So these are all the basic components of packet core, right? And there are some auxiliary nodes which are which contribute in setting up our PS core services. So we mentioned them in the network architecture as well. These are your BSCs, you have your RNCs, you have your E-node Bs, you have your OCS, you have your HSS and HLR, and a few other nodes. So basic nodes are these, okay? So in 2G architecture, if you're connected to a 2G network, you're going to be connected to your BTS. That BTS will connect to your BSC, and from BSC, you're going to connect to your SDSN. When we talk about 3G, in 3G, you have the UMTS network where the basic element is node B. Your node B gets connected to your RNC, radio network controller. And then your radio network controller is the entity that connects with our PS4 NE, the SDSN, right? And in 4G architecture, we have eNode Bs, and these eNode Bs are directly connected with our SDSN and the SDW nodes. Okay, a little bit of difference in the architecture of 2G, 3G, and 4G PS4. So we will come to that in the next slide. And so, okay, right. So we have, so here it's a little bit of more elaborative network architecture. So in 2G, 3G, you see you have GRAN and you have UTRAN. All of these, both of these radio network elements, they connect with SDSN. Okay, and then your SDSN is connected with your GGSN. SDSN connects with your HLR. The SDSN is connected with other SDSN as well, right? And then your GGSN connects with your OCS. OCS is used to charge. Then your GGSN is connected with your Pcrf. Pcrf is for policy control. We will come to the description of these nodes in the later slides, okay? And then your GGSN is mainly responsible for communicating with your ISPs, okay? So if a user is connected with 2G, like your handset is connected with 2G, you are going to connect to your BSC. Your requests will then come to SDSN. The SDSN is going to perform authentication from HLR and authorization. These call flows are going to be covered in the later slides. This is just to give you a brief overview of how your communication happens, okay? So your SDSN performs authentication from HLR, from equipment identity register as well. There is another, and your handset as well. And once all your authentication is done, then your SDSN communicates with your GGSN. The GGSN has its own functionality. It performs charging from OCS. It gets the different rules that are defined from Pcrf. And once all the authentication, authorization, and its internal processing is done, the GGSN provides the handset with your IP address, and then you communicate from your radio interface to the SDSN, from SDSN to GGSN, and from the GGSN you go towards the internet. When we come to 4G architecture, in 4G architecture, there is a little bit of change in the PS core architecture. What 3GPP has done is that they have broken down some part of the SDSN and some part of the GGSN has been broken down, and they have made a separate entity called the serving gateway. Okay, so now you have three networking elements, the base networking elements. You have MME, you have SGW, and you have TGW. So any user that is connected with 4G eNode B that uses initial request comes to your MME, which is handling your mobility management entity, which is handling all the selling part. Then your MME performs your authentication. So MME is connected with your HSS. So it performs authentication from HSS. You have equipment identity register as well for authenticating your mobile entity. And once your authentication is completed, then your MME selects a serving gateway based on your specific location. So if you're in a one specific location, you'll be communicating with one serving gateway. If your location is different, like in 4G, the location detail which will come afterward is called tracking area code. So when you have a different tracking area code, so based on that tracking area code, you will be assigned a different serving gateway. So serving gateway has its own functionality, and it will support to select, apart from other things, it will support to select your PDN gateway as well. Your PDN gateway is just like GGSN. Majority of its functionality is performed by your TGW, and this is selected based on your APN, your access point name, which is configured in your handset. We will come to that afterwards. How your APN, how the APN is assigned, and based on APN, how the GGSN is assigned, and how based on APN your IP address is assigned. Okay, so just a basic overview that how what is the basic functionality of the MME, the basic functionality of SDW, and the basic functionality of the PDN gateway. The main thing I wanted to cover in this slide, like the previous one, and including this, is the major network elements. So every one of you should know what are the major network elements in the PS core. Okay, so you have your SDSN, you have your GGSN, you have HSS, not part of the PS core, but it supports it. You have your OCS, you have Pcrf, you have DNS as well. It's not added here. Okay, so this part is your 2G, 3G, and when you come to your 4G architecture, you have MME, you have serving gateway, you have PDN gateway, you have HSS, you have OCS, you have Pcrf as well, you have DNS as well, you have charging gateway as well. We will come to that afterwards as well. So these are the basic networking elements which you should know, and how these networking elements are connected with each other. Okay. The next thing that comes is the interfaces. Okay. The main thing that comes afterwards is the interfaces. So the interface that your 2G network element communicates with your SDSN over is the GB interface. Okay, so you can remember it from BSC, that BSC connects your SDSN over GB interface. Okay, so if you have two SDSN or two SNs available, so each of the interface is going to be called GB interface. The next interface is the interface between SDSN and GGSN. So that interface is called GN interface. Okay, so the next one is SDSN and GGSN, and this interface is called GN interface. So you can remember it that it's between SDSN and GGSN. So from this N, you can remember that it's called GN interface. Okay. The next interface that is very frequently used is the GR interface, or your authentication, authorization, location abilities performed on the HLR. So it's called GR interface. So you can remember it with HLR. So you can pick up the R from here, and you can remember that this is called the GR interface. Okay. In case of roaming, if you're performing international roaming, it's a bit complicated case, but just to remember as a basics, the interface between your local SDSN and your roaming partner GGSN, or your roaming partner SDSN and your local GGSN is called GP interface. Okay. Yes, the explanation about the interfaces, we are going to cover it with. We will go a little bit, we have the slides on them, so we can, this is just a basic overview of what are the basic interfaces, okay? And the interface, which protocols are being run on the interface and all that, those are coming in the next slides. Okay. So we have covered GB interface, we have covered GN interface, we have covered GR interface, and we have covered GP interface. The next essential interface that you come across is the GY interface. This interface is between your GGSN or your PGW and the OCS. OCS, as I'm mentioned, that OCS is your online charging systems. So you can just get a brief understanding that online charging system is basically where all the charging of your packets services are done. Okay, so GGSN and OCS is your GY interface, and GGSN and Pcrf, where your policies are configured, is the GX interface. So both of these are running on the diameter protocols. So we will come to this, the detailed explanation of the interface afterwards. Okay. So these are the interfaces in your 2G, 3G. In 4G, the 3GPP has renamed the interfaces. Okay. So the first primary interface that you come across is between your QSN or your mobility management entity and your eNodeB, and this one is called S1 MME. Okay. So when your connectivity between your eNodeB and your MME is via S1 MME interface. Okay. And the connectivity with your eNodeB and your serving gateway, your SGW, is via S1 U interface. So U for user plane. And we come across the functionality of these. I'm going to explain that your signaling is done via MME and your user plane traffic goes to your serving gateway. Yasir, we will come to charging. A little bit wait, okay? You guys are going in advance. We will slowly proceed towards that, because a few of my colleagues that I personally know, they don't have any idea of what PS4 is. So we will come to this advanced level question afterwards, okay? Right, so S1U interface, the next main interface that you come across is between your SGW and PGW, and this is called your S5 interface. If you come across training module, it will say S5 and S8 interface. So S8 is similar to what we discussed in GP. When you are on roaming, or you so your local SGW and your roaming PGW, or your roaming SGW and your local PGW, the interface here is called S8 interface. So the communication is the same. However, to differentiate between the local communication and the roaming communication, we have different interfaces, S5 interface and the S8 interface. So the next one is the equivalent of GR interface. So in 4G, we have HSS. Okay. In 2G, 3G, we used to have home location register. In 4G, we have an equivalent called HSS. And the interface that is working here is your S6a interface. Okay. S6a and S6d, depending on whether MME is communicating with HSS or whether your SGSN is communicating with your HSS. Okay, so GR equivalent to S6A, your GNGP equivalent to S5 and S8, then your GB interface is equivalent to your S1 and MME and your S1U. Okay, and with communication with your OCS, the interface is the same. It's GY interface, and communication with Pcrf is the same. It's the GX interface. Okay, and unless interface, which is not mentioned here, is your GI interface. So in 2G, 3G, your GGSN communicates with your internet over the GI interface. And when you come to 4G, that same interface is called SGI interface. Okay, so you have GI interface over here, and you have SGI interface over here. Okay. PDN interface, PDN gateway and GGSN is basically the same. GGSN is basically used in 2G, 3G. And in 4G, the 3GPP has renamed it because it has provided some of the functionality of the GGSN and ESGSN. So some of the functionality has been provided into SDW, and the remaining part is basically called the PGW. So for basics understanding, you can call the GGSN and PDN gateway is the same, because 90% of its functionality is the same. Only the 10% of its functionality has been moved to signaling gateway. Okay, S6d interface is usually used when your HSS is communicating with your SDSN. Okay, so if you have SDSN that is communicating with your HSS, so you have S6d. Otherwise, it is S6a interface. Okay, one more interface which I missed is that if you are connected with 3G, in that case, all the remaining terminologies, all the remaining interfaces are going to be the same. The interface on which your RNC communicates with your SDSN is called IU interface. To be very specific, it's IUPS interface, because the same RNC is communicating with your MSC as well. So that is over IUCS interface. So this is called, basically it's called IU, but specifically it's called IUPS interface. The rest of the protocol, the rest of the interfaces are the same. Okay. So we have covered the basic network elements. We have covered the basic interfaces, and we have covered the basic nodes which are being used for communicating with all of the nodes. Communicating with. Okay, so let's move to the next slide. Okay, any questions? Let's see. Okay, control and user plane example. Saddam example is going to come afterwards. Okay, we're just going. Okay, what is the difference between control plane and user plane? What is the name of the PGW and IMS called? Okay, PGW and IMS is the same. It's SGI interface. Okay, SGI interface here. The main difference between control plane and user plane is control plane is all this signaling. When we will come afterwards, like you perform location update, you perform attach, create Pdp context, you have diameter. All this signaling is done over control plane. And user plane is basically when you have your internet services, like you're performing browsing, you're performing voice over IP call, you have your different applications which are communicating. So all that part, the user related traffic is done over the user plane, and the signaling communication is done over the control planes. So this is the difference between that. I think Yasser has answered that. That's great. So control plane example, I think Yasser has explained that very well. Okay. Okay, so a little bit of abbreviation. I believe 70% of you has been knowing this, but the rest of the 30%, like Asan and others. So SDSN is serving GPRS support node. GGSN is your gateway GPRS support node. Pcrf is your policy control and charging rules functions. So a little bit of information on SDSN. I told you that SDSN is the first NE in the PS4 network that is communicating with your radio network elements. Okay, so that and it performs your authentication with your HLR, your identity authentication with your EIR, and your communication with your DNS as well. The DNS functionality I'm going to mention later. The GGSN gateway GPRS support node, communication with your OCS, communication with your Pcrf, and then further communication with order gateway if required, and the communication with your internet service providers. Pcrf is policy control and charging rules function. This is a new element that was added afterwards. The purpose of this is to create different policy rules. Like, for example, I will give you a very basic example that, okay, you want to browse, you want to perform basic website browsing, like you want to search something on Yahoo and Google. So for that browsing, there is no need to assign you a speed of 3 Mbps or 5 Mbps. Okay, if you are assigned a speed of 200 kb or even 512 kbps, that is fine if you want to perform basic level browsing. But if you want to perform video streaming, or you want to have a video call or something like that, an application that requires high speed, so for that, you require a bearer, you require a higher speed. So the functionality of the policy control and charging function is that you assign different services to it, and then you assign different rules to it. So that if you are using an application that does not require that much of a speed, so you are assigned a speed that is limited to your functionality. And if you are using a service which requires higher speeds, so you're assigned bearer and you're assigned a speed which is controlled by your PGSN. Okay. PDSN is a technology because we are all talking about the GSM technology. If you talk about the CDMA technology, the SGSN and GGSN has a combined functionality that is called PDSN. But I don't think PDSN in Pakistan, I don't think anyone is using. PDCL used to use this, but right now it's not. So we're not covering PDSN in this one. Okay. GRAN is what GRAN stands for is GSM as radio access network. Basically what we in normal terminology know as 2G. UTRAN is 3G, and EUTRAN, evolved UMTS, is your LTE or what we call 4G. MME stands for Mobility Management Entity. SGW stands for Serving Gateway. PGW stands for PDN Gateway. LTE is your long-term evolution, which is a terminology used for 4G. SAE is System Architecture Evolution. It is basically a combination of LTE and EP. So LTE is basically the terminology of 4G on the radio side, and EPC, Evolved Packet Core, is the 4G terminology on the core side. So if you combine if you combine LTE and EPC, so it's commonly known as SAE, System Architecture Evolution. Okay, so a little bit of functionality of SGSN. Okay, so SGSN handles the communication with a mobile station and establishment of the connection between MS and the PDN. Okay, so at a glance, what you see is that it serves the mobile station in an SGSN area. Okay, so what you have is that, I mean, in a country like, if you talk about Pakistan, so we have main 4 different regions. We have North region, we have Central region, we have South region as well. Okay, so if we talk about 3 regions, so deployment is done so that the nodes in the North region are going to be communicating with the SGSN in the North region. Ones in the Central are going to be communicating with the node in the Central region. The one in the South are going to be communicating with the SGSN in the Central region. So it's a mobile station in a specific SGSN area. The second functionality is mobility management function. So when you talk about mobility management, you can take a cue from mobility. Its responsibility is to track the mobility of a user. If I am in one area and then I'm moving to another area, so it's SGSN responsibility to track my location where I'm going. The basic terminology that identifies an area in packet core is called routing area. So if I move from one routing area to another routing area, my handset is going to send an update to the SGSN intimating that, okay, my location has changed. What you can see here as well is routing area update. So there are 2 types of routing area update. And we are going to come into this signaling flows. I will explain to you that what routing area update is, but the mobility management function is that it tracks the mobility of specific users. Okay. Its third functionality is handling this signaling. Like all of these are the call flows, like update location, outing area update, you have attach, you have paging, you have create session request, and all that. So all these procedures are basically handled by your SDSN node. Okay. The next one is your security and access control. Like if I want to restrict a specific user from using PS4 services, or if I want to restrict a specific operator, like if we have a roaming agreement with different operator and I don't have a roaming agreement with a specific operator, so I have the functionality to stop the users of those specific roaming partner to use packet core services using my SDS. And then apart from that, we have your security. In security, it is responsible for authentication. Like I mentioned that the communication with HLR is for authentication. Then you have identity requests as well. Asif, if you can mute, please. I think you are unmuted. Yes, please. Thank you. Okay, so in security, we have your authentication with your HLR, authentication with your EIR, and your some security control like communicating, like you have your access control list. I can even block a specific area, like there is a specific area in which I don't want the mobile services to work. So I can add that area in the SDSN, and then SDSN is not going to allow any user in that specific area to use PS services. Authentication, ciphering, setting, and IMEI check, I already explained. The authentication with your HLR, cipher setting with your HLR in case of 3G, and your IMEI check is with your equipment identity register to ensure that only white listed handsets are allowed to use the service, and those handsets which are blacklisted are not allowed to use the service. Okay, what is lawful interception actually means? Fakhar, we have not reached lawful interception. When we will reach, I will explain to it. For paging will come afterwards. We have call flows. We will have the detailed signaling flow, okay, for paging, and then we will cover that part afterward. Yes, I think Yasser has, because Yasser is working on lawful interception, so Yasser can better explain what lawful interception is, but I will also give a little bit of idea of what lawful interception is. Okay, so routing and traffic management. This is to route, like your SDSN then routes your services to a specific CGSN. So it is defined in the SDSN that on which GGSN, based on your access point name, which CGSN should which GGSN is providing this services of this specific access point name APN. So you can route. I mean, if you come a little bit back, so the routing is done like this is the SDSN. So SDSN has the option of sending the request to this PGSN. It has the option of sending the routing your request to this GGSN. It has the option of routing your request to PDN gateway as well. So this routing is done based on which access point name there is. It depends on which whether it is a 2G user, whether it's a 3G user, and there are any other options available based on which you can route your traffic to a specific GGSN. Okay, the next functionality is collecting charging data. Okay, your SDSN is connected with your charging gateway as well, and SDSN based on all the services which you are using the SDSN creates CDRs as well. And those CDRs are then sent to your charging gateway. Then the charging gateway is connected with your billing system, and your billing system then processes that how much data you have consumed, and based on that, how much you need to be charged. This was an old mechanism. Right now we have OCS, and in OCS you can perform online charging and offline. So right now the charging data that is processed by the SDSN, or even for that sake for GGSN, that is usually used for reconciliation. Like you have the charging information available in OCS, and to reconcile that, to check that okay, there are no anomalies in that, the charging information that is provided by SDSN, GGSN via the CDRs is then used over there. And apart from that, you have different data warehouse team, you have billing team, you have IT team. They are processing, they are post processing this information. They are creating reports, they are creating dashboards and all that. And based on that, the marketing team is developing their policies. So that also is done from the charging data, the CDRs that are collected. Okay. Realizes the interfaces. So these are all the interfaces that the SDSN is communicating. So we already covered this, that which traffic needs to send to the GN interface towards the GGSN, which traffic needs to be sent towards your GB interface, that is the communication that is coming from DSC. GD is an interface that I did not cover. GD is an interface if you are performing SMS via SDSN. In 4G, the SMS is done. In 2G, 3G, I don't remember if any operator opened this license to send an SMS service. But for if you needed to do SMS using your SDSN and not via SSMSC, so this was one interface that was used for communication with SMSC. GP, we covered that it's for roaming, roaming PGSN and local SDSN or vice versa. GR is your, you can recognize from R. It's with communication with your HLR. GS is another interface which we did not cover because it's previously it was not very frequently used. Right now it is. GS is your interface with your MST. So your SDSN, when you have a combined location update, which we will cover in the slides of the flows. So if you have a combined location update, like you need to update the location in SDSN and you need to update your location in MSC as well. So that is done over GS interface. Or if MSC wants to communicate with SDSN for any location information, so that is done over GS interface. And GF interface is your interface with your IMEI check. So this is another entity, EIR, Equipment Identity Register. And if you need to check whether your handset is blacklisted or whitelisted, you need to allow or not. So IMEI check is performed over GF interface. Okay, the next is control subscribers in its service area. So it's the controlling, like if you have any paging request, so page a subscriber in the area, in the routing area, which is defined in the SDSN. So that is done by SDSN. Lawful interception is basically, as you can understand from the terminology, it's interception and it is lawful. What happens is that you have different intelligence agencies that need to keep a track on some of the subscribers. So what they do is that we have a link. The SDSN and the GGSN has a link with the servers of your LEAs, and on those interfaces we send some specific information, which can then help them keep a track on what the subscriber, where the subscriber is located, what sort of services that subscriber is using, and all that. So since it is lawful interception, so all the communication of some specific users, depending on the law enforcement agencies, they can intercept they have an interface available and they can intercept the traffic of those specific MSISDN or IMSIs which they need to track. So this is also functionality that SDSN supports. Okay. So I will come to this. The routing area update, I think I explained that when you move from one routing area to another routing area, so that is called routing area update. Its flow I'm going to explain afterwards. Location update for CS, this is used for your GS interface. Attach, detach, this is the basic flow of the PS. I mean, if you perform, if you turn your data services on, so you will initially perform an attached request, and if you turn your data services on, so you will be detached from PS core network in case of 2G, 3G. In 4G, the flow is a little bit different. PTMZ allocation, reallocation, this I will cover afterwards. I'll give a little bit of brief view is that when your subscription is authenticated in SDSN and you're successfully attached with the SDSN, you do not communicate with your IMSI. You are allocated a temporary mobile subscriber identity, and it is for packet core usage, so it's called PTMZ allocation. So once we will study the attached flow, I will explain that where PTMZ is allocated, and if you have a further attached request after some time, so your PTMZ is reallocated as well. Authentication, as I explained, authentication is via your EIR, and your authentication is via your HLR as well. So authentication is done. Paging. Okay, paging, PS and CS. Paging is that when you have, for example, you have an application installed, or you are sending WhatsApp message to a friend of yours. If that friend is not currently connected to your SDSN, so your GGSN is going to find from HLR that which SDSN has your contacts available, and then your SDSN will then page you based on your last routing area. So on that routing area, a paging request is sent, which will initiate your handset to establish a radio connection because you have an incoming packet service available. It can be in the form of a handset application update. It can be in the form of an incoming message. It can be in the form of any other packet service that is originated from the ISP. So if you're not connected with the packet core services, so a paging request is sent, which informs you that okay, there is a packet available in the PS core. Some information available that needs to be communicated to your handset. So you need to establish your radio connectivity with the PS core NE so that you are able to receive that information that is available. Okay. Okay, more details at SDSN interfaces. Okay, let's go a little bit. Okay, confusion. Okay, okay. Okay, SDSN. Okay, so more details of the SDSN interfaces. Can we for SDSN to send a routing area update, routing area identity during PDP activation, and what is the impact? Look, routing area update is basically routing area is basically sent routing area RAI is routing area identity. Routing area identity is usually sent by the handset. I mean, if your handset is located in a specific routing area ID, and if it changes its routing area ID, then it will send a routing area update to your SDSN. So during PDP activation, first you have to be attached. When you get attached, you send a routing area information to your SDSN. And once you create a PDP activation, yes, you have a routing area information in that PDP request as well. But if your routing area is changed in that time, then obviously you will have a routing area update first. And after that, you will send a PDP activation request. But SDSN cannot force to send an RAI to a specific user. I mean, you can remove Okay. Okay, so you want to say that towards Roma GGSN. And don't send RAI to Romer's GGSN. This is configurable in your SDSN, like on the GN or on the GP interface or on the S8 interface. Which sort of information you need to send over your S8 interface or a GP interface. This is something that is configurable in the SN management different session management configuration that is available in your SDSN or your MME. So you can configure which information you need to send in this session management and which information you need to need to skip in order to not to send to your GGSN or your EGW. Okay. Does it have impact to address IE? This, my brother, I cannot answer because I'm not that much of an expert. I've not worked in the R&D. So if you're adding an IE in Create Pdp, it's better that you ask because I don't know which vendor packet core you have. I think that vendor can better communicate whether if you want to enable an IE or something like that. If it's not available, currently not configured, you need to do some development or add. So it's something that they can answer. Usually your routing area information is usually your location information is sent, but if it's not sent or it's not enabled, I don't have the context of that why it's not enabled. So it's something that they can better answer. I'm not in a position to answer to know exactly comment whether it will have an impact or not. Okay, a lawful interception. Yes, there is more. We can have a session on lawful interception, like I mentioned in the start. In this session, I'm just going to cover the basics. Okay, I'm just going to tell you what LI is, how LI works, and exactly the interfaces X1, X2, X3. We can have a session on that, and I think I'll ask Yasir Javed because he is he has been working on this, so he can deliver us a session on that. So we can have that. We can have that at a later stage. Okay, to have a session on that. Jawad, more details on paging. We will cover paging when we'll come to the call flows of paging. Right now, we're not covering that. We have a little bit of information available, a little bit of description of the NEs. And later on, when we come to our training session, where we will cover the call flow. So obviously, we will cover what is routing area. We will cover what is create PDP context. We will cover what is paging. We will cover what is inter-SDSN and intra-SDSN routing area update. Okay, so we will cover all of that. Okay. Okay, so next NE is GGSN, the Gateway GPRS Support Node. SDSN handles the communication with MSN is served between MSN TDN. Okay, so GGSN is basically responsible for basically communicating, because what you send, what your handset is requesting, as you know that packet core services, it is all about IP communication. Okay, or your URLs that you're communicating or the application in your handset communicating are IP based. But your SIM is MSISDN or IMSI based. So the basic thing that a packet core network needs to do is that it needs to assign you an IP address. So the main functionality of the GGSN is assignment of an IP. Okay, in your handset, you configure an APN, an access point name. Based on that APN, the major functionality of GGSN is to assign you an IP address, and then it simply acts as a router. It routes your traffic towards your ISP, and from ISP, it routes traffic back to your SDSN and then to your handset. Okay. So functionality as a branch, it acts as an interface and a router to external networks. External network means anything that is on the internet service provider side. any website, any application, any hosted URL. So it acts as an interface. It is, you have your handset, we come here, okay? You have your handset over here, and you have your GGSN over here. So this is the first interface. Any traffic that is coming from your internet, GGSN is the first interface. That comes here, then GGSN and okay, this communication is for this specific IP address and this specific IP address and this specific. So it sent that request to your handset based on the IP address which your handset is assigned. Okay, so it acts as an interface and a router. Router is simply routes based on the source IP address, which is your specific hosted URL, and your destination IP address, which is the IP address of your handset. It acts as a router. It routes your traffic towards SDSN, and from SDSN, it routes your traffic towards your handset. Okay. Then it contains routing information for GPRS mobiles. Okay, so routing information, like if you have a specific APN, I'll say that I have an APN for web services, so it has the routing information that okay, which where do I need to route my if any communication is coming for web APN, so where to route it to. If it is for normal internet, where to route it to. If like I believe MMS is an obsolete technology, but when you used to have MMS, so it was responsibility of the GGSN to okay route this. Okay, so when I have this packet with me, and I know that this is an MMS service, so it's GGSN responsibility. It has the routing information that where to route the service to the MMS service. If you send an MMS and it sends a request towards your ISP, so obviously that service, that specific request is going to fail. So it has the routing information. That okay, if the source IP is this and the destination IP is this and the APN is this, so where do I need to route this request to? So I can route it towards a web server. I can route it towards an MMS server, route it towards ISP. That all depends on what is my source IP address and what is the APN that I am utilizing. Convey packet through the IP-based internal backbone. So it's all your IP. The tunneling part, I'm going to come afterwards. I mean, if you have a PDP session created, so you have a packet at a protocol tunnel is created. Like if you have two APNs, you are using MMS APN and you're using an internet APN. So you're going to have two different tunnels available. One virtual tunnel is something is going to be your communication between a handset and your MMS service, and the other tunnel is going to be your communication between a handset and your internet service. So your IP-based internal backbone tunneling works in that way. Or in case you have okay, about APN. Okay, APN. We will cover APN afterwards. Okay, and connected to firewall to communicate with internet. Umar, this is a little bit advanced level question. We will come to it afterwards. Okay. Because if I start explaining it here, most of the people are not going to understand what we are communicating with. So I want everyone to be at the same level, okay? So all those questions that I'm not answering, you guys can send those questions to me on my number. I will mark those questions, and when we come to the relevant topic, I'm going to answer each and every one of your questions, okay? So we can discuss it, and we're going to discuss GGSN and its connectivity with firewalls. So we can have the discussion over there as well. The next functionality is collects charging data. Just like SDSN, the GGSN also creates CDRs. GGSN is connected with charging gateway as well. And the GGSN CDRs are used both for the roamers as well, as well as focals as well. So a little bit of more information. The CDRs that are created by SGSN are called SCDRs. You can remember those from the SGSN's S, so is called SCDR, and those created by the GGSN are called GCDRs. So functionality of the CDRs is the same. In older times, those CDRs were used to process and the charge a subscriber, but right now, since our OCS is charging both your postpaid and prepaid subscribers, so this CDR is just used to just validate the OCS CDRs and the post-processing done by our data warehouse team and our IT teams and our BSS teams. Okay, so this is something that we keep in our charging gateway. The charging gateway is then connected with the billing system, and then the billing system either imports it or we export it towards them. Okay, packet filter for incoming traffic. Okay, so if I have a requirement that I need to block a specific URL, let's say I need to block yahoo.com. Okay, so I have this provision available in GGSN that I can filter the incoming traffic. For example, my handset has an IP, let's say 10.1.2.3, and the Yahoo URLs has, because each URL has many IP addresses. So let's say for example, in my network, I need to block the traffic towards IP address, let's say 10.2.2.2. So I have the option of defining this IP address in GGSN, and then I can ensure that any traffic that is going towards this specific IP address is blocked. So this way, any subscriber that is attached to my GGSN will not be able to use the traffic towards any specific IP address if I need to block it. Packet inspection. This is a concept in the GGSN, which most of you must be knowing, and those who do not know, no issue in that. It's called deep packet inspection. Deep packeting or packet inspection is something that you can understand from this terminology, that it inspects a packet. Since it's IP to IP communication and it's a packet-based communication, so GGSN has the option of inspecting a packet. By inspecting a packet, it means that it opens up a packet. If you guys must be familiar with different TCP IP layers, okay? So in layer 7, like your normal routers and switches are communicating over layer 3 and layer 4. Layer 3 is IP-based, layer 4 is code-based. So GGSN has the option of opening the packet at layer 7 as well. Okay, so if I need to define a specific rule, for example, I need to, my marketing team tells me that, okay, you need to make WhatsApp traffic free. So what I do is that I have the option available in GGSN to open the packet and see that, okay, my communication is going towards WhatsApp IP addresses, or if I need to make some specific URL as free, so I can open that specific each and every packet, and GGSN can check that, okay, this traffic is going toward this specific URL, and then I can define some policies in the GGSN to ensure that, okay, this traffic should be free or this traffic should be charged according to a specific tariff plan. Okay, so packet inspection is another functionality which GGSN can perform, and this is something that is majority used. The GGSN is nowadays, if you look at the configuration of GGSN, I think the 60-70% of your configuration is based on your DPIs. You define your filters, you define your rules, you define your filter groups, you define your CVV IDs, and then you define whether to allow the traffic, assign some specific RGs to it. So it's all based on deep packet inspection. Gateway with online charging system. This, I think, I also mentioned before on the Gui interface. If you see, that this is OCS. Okay, so whether it's GGSN, whether it's your PDN gateway, it has an interface of GUI with OCS, and its functionality is to charge a subscriber. So in GGSN, any traffic that is coming using packet inspection, the GGS identify that okay, which rating group I need to assign to it, and then it assigns that rating group to it, and then it sends it to your online charging system, and then online charging system see that okay, according to this rating group, how much do I need to charge this subscriber, and once its charging is authenticated, only then GGSN allows that packet to go through. So if you don't have sufficient balance available, your service is going to be blocked at the GGSN level. Why? Because it communicates with online charging system, and if the OCS authenticate that okay, you have sufficient quota available, then it will allow you to pass your traffic, allow you to perform browsing or any other communication. If you don't have sufficient available, sufficient quota, sufficient balance available, then it is going to block your service. Tunnel creation, Umar, tunnel creation is, we will cover this when we come to the flow of PDP. When we discuss how a PDP is created. So after that is part of my slide that I'll show you that how a tunnel is created. Like if you have one service, a tunnel for one service, if you have another APN that will have as a tunnel for another service, so it will be covered in that. Okay, the next node of packet core is called DNS. DNS is domain name system or domain name server. Okay, the functionality of the DNS is basically it has the main functionality is that it resolves your URLs or your alphanumeric characters into an IP address. So this happens at two places. One place is that you have an access point name, you have an APN, you configure an APN into your handset, you bring that. So when you create a PDP, you bring a specific APN. For example, I bring an APN ABC. Now all the communication between SDSN and GGSN is based on IP address. So once the SDSN gets that APN ABC, it will send the request to DNS to resolve that APN into a GGSN IP address, because SDSN needs to communicate with your GGSN. So we will come back to this. Okay, so we have DNS connected here. It's not mentioned here. So once your request comes to your SDSN, the SDSN is going to see that, okay, the DNS, the APN here is ABC. Okay, so based on this ABC, which GGSN do I need to select? Do I need to select this GGSN? Or is this APN being served by this GGSN? Or is this APN being served by this PGW or GGSN? So this ABC is resolved into the GGSN IP address by DNS. Okay. So it resolved the APN to a GGSN IP in the PDP active procedure. So this we will come into detail and we will discuss the call flows. So your APN resolution into GGSN IP address. Okay. The next is resolve your routing area ID to an SDSN IP address in inter-SDSN routing area update procedure. You will better understand this when we will discuss the inter-SDSN. But what happens is that I am being served by, for example, we come back to this. Let's say I am being served by this SDSN because my location was somewhere here. I then move to this location, and this location, the BSC is connected with this GGSN, is not with this SDSN, not connected with this SDSN. So what happens is that my context is saved in this SDSN. So once I move to this location, my request is going to come to this SDSN, and it is going to be an inter-SDSN routing area update. Okay. So once it comes here, the SDSN is going to recognize that, okay, I don't have this context, but the user has brought his old routing area ID. So this location has its own routing area ID. This one has its own routing area ID. So based on that routing area ID, it is going to determine that, okay, which one is the previous SDSN which was serving this subscriber. So it will go to the DNS. It will give the DNS, okay, this is the old routing area ID. Please confirm to me what is the IP address of the old SDSN. So DNS is going to resolve that routing area ID, this routing area ID, into this SDSN IP address. So this is something we configure in the DNS. So when we come into the inter SDSN routing area update procedure, it will be more clear to you, but a little bit of brief information that it resolves the routing area to SDSN IP address. And the third is a similar procedure. If you in 3G, if your RNC is changed, so it will resolve your RNC ID to an SDSN IP address in the relocation procedure. If you are coming from the coverage of one RNC to a coverage of another RNC, obviously you need to know that which was the previous RNC that has the packets available of the packet corresponding to this available. So it will resolve that RNC to this SDSN IP address, and then the new SDSN can get the context and all the information from the old SDSN IP to its new SDSN. So this again will be more clear to you once we cover the call flows. So this is the functionality of internal DNS. So we have two DNSs. One is the internal DNS, which is part of the PS core architecture. And we have an external DNS as well. The external DNS, I will call it external DNS, is that it is responsibility is basically it is hosted in your ISPs. Some of the operators also have this information, but usually it is hosted in the ISPs, and there its responsibility is very simple. Resolve the URLs to an IP address. For example, when you are browsing, you don't browse that, okay, you mention a website IP address 119.160 something, you mention yahoo.com. But since packet core communication is all IP communications, so just like your MSSDN or your IMSI is assigned an IP address against the APN, same goes for the URL. Your specific URL that you're going to browse is converted to an IP address. So this is done by your external DNS. So your internal DNS has these three functionalities, and your external DNS has the functionality of resolving a URL into an IP address. Acha, Yasir. Ahsan says there is this, try to reconnect. Ahsan, can you hear me now? Okay. I think I have given you the option of unmuting yourself as well, so you guys can unmute. Okay. Please check if you can unmute. Ahsan, आ रही है आवाज? मेरी आवाज तो आ रही है, आपकी आवाज मुझे नहीं आ रही. No, I cannot hear Ahsan. Ahsan, you are unmuted. Bakas?
Usman, yes. Yes. Usman, we can hear you, but Usman?
Yes.
We can hear you. Okay. We can hear you.
Ahsan, I suggest that, okay, so you can hear me as well. Okay, that's good.
I think it's better as everybody should ask question in the chat. It's better.
Yes, I think that is better.
Yeah.
That is okay. Great. Okay, so Yasir, you wanted me to explain the internal DNS as well. Okay, internal DNS. What happens, Yasir, is that you may not be seeing the internal DNS installed because what the 3GPP and all the vendors have done is that they have incorporated the DNS inside the SDSN as well. So if you look at the configuration of the SDSN, you will see that there is a DNS host file. So actually, internal DNS is installed, but that is just used for roaming. For your local communication, what you do is that there is an option available in the SDSN. I mean, in the older SDSNs, I remember in Alcatel SDSN or in the Nokia Siemens network, SDSN did not have this concept of DNS host file, but the advanced ones, right now, the Nokia SDSN as well, I believe, Huawei, ZTE, all of them have this option of DNS host file. So what we do right now is that for resolving this GGSN, for resolving this APN to GGSN, routing area ID to SDSN, and even RNC ID to SDSN IP, what we do is that we have a DNS host file, and in this host file, we define that, okay, if this is the APN, then this should be the GGSN IP address. And if this is the routing area that is brought by the neighboring RAI, it should be resolved to this specific SDSN IP and even the RNC ID. The internal DNS, another functionality of the internal DNS is when you are performing international roaming. For example, someone from Oman comes to Pakistan and he wants to use the services on the same MSIDN which he has. Okay, so we have a roaming agreement with Oman. So once his create PDP request, again, this is going to be more clearer when we discuss the call flow, but a little bit of overview is that when he sends a create PDP request, so his APN information I will not have in my DNS because I cannot define each and every global APN in my host file. So what I do is that I define the APN RS RC only from my local network in my DNS host file. The rest of the information I assign to my DNS, my internal DNS. So if someone from Oman comes here and he has an APN called Omantel, so he sends a create PDP request of Omantel, I will not recognize it. The SDSN will not recognize it, and the SDSN is going to send that request to the internal DNS. In the internal DNS, there is an option available because all of the operators' internal DNSs are connected with the global DNS, which is called root DNS. Okay, when you purchase roaming services from a roaming service provider, so it has a root DNS. So that DNS has the information of all the global operators' DNS information and all the global global operators' GGSN IP address as well. So that APN then goes to your root DNS. Your root DNS will recognize that, okay, this will be handled by Omantel DNS. So it will give me the IP address of the Omantel DNS. Then my DNS is going to send a request to the Omantel DNS. The Omantel DNS will have this APN resolution available. They are going to send me the GGSN IP address of the Omantel DGSN, and then my SDSN is going to communicate with this. So it's a bit of a complicated procedure. We will cover this when we will come towards the roaming cases. So the create PDP and how roaming is handled in that. Okay. But from local perspective, usually in our internal DNS, we don't do this. This is done by the DNS host file, but we have the option available that we can define our APNs in that and assign specific GGSN IPs to it. We can assign the routing area IDs and assign the SDSN IP to it. Again, this will become clear when we discuss these routing area update procedure and PDP activation procedures. Right now, you can just understand this part that, okay, we have two types of DNS. One is the internal DNS and one is the external DNS. The internal DNS handles your internal APN and routing area ID conversion, and your external DNS handles your URLs to IP address conversions. Okay, so next, NE is Pcrf, policy and charging rule function. It's a policy server. It provides centralized policy management according to 3GPP policy and charging architecture. Like I explained to you that this is a very basic example that I need to control the speed based on the service which I'm using. So a little bit of advanced functionality is that I have the option of authorizing, like the OCS has the function of authorization. I have the bundles defined in Pcrf as well, and I have the option of authorizing the service usage or not. If a user has consumed, consume 75% of his quota, so I can downgrade his service. Or I want to redirect his services for example, a user has purchased 20 GB bundle, and he has consumed 75% of that information. 75% of the quota has been consumed. So once that the 25% is left, I have the option in Pcrf that okay, Pcrf maintains the quota, and it can redirect me to a website or redirect me to a specific message which says that okay, 75% of our quota has been exhausted and 25% quota is left. And with management, again, this can be done in two different ways. The one way is that based on a specific service, if I'm using a browsing service, so I can define in the rule that if I'm browsing, I need to be assigned less bandwidth. And if I'm using streaming services or any other service that requires more bandwidth, so I'm assigned a higher amount of bandwidth. The other thing is based on my consumption. For example, I have 20 GB quota that I purchased. So what I can do is that for the first 10 GB, I am given 20 Mbps. Once once this 50% quota is exhausted, I can downgrade the speed to, let's say, 10 Mbps. And if my 75% quota is exhausted, I can downgrade the speed to like 1 Mbps or even 512 Mbps as well. So this is basically to ensure that as more and more of my quota is being consumed, I am consuming less and less speed in order to ensure that there is fair usage policy implemented at Pcrf as well. Okay. Next is service-based routing. This is usually used when we need to launch a service in a specific area. For example, I want to launch a service in, let's say, area defined as ABC. So what I say is that okay, the users in area ABC are not consuming that much data. So what I need to do is that I need to enhance the bandwidth that is assigned to them, and I need to charge them half. So based on the routing area ID of that area, I can define a policy that any user who's sending a request from that specific service area is given a specific quota, given a specific enhanced bandwidth, and is charged less. So this location-based, what you call is location-based policies. These location-based policies are defined in Pcrf. Content filtering is also available, just like your GGSN does your DPI, deep packet inspection. This is available in Pcrf as well. So if you want to offload the computation from your GGSN, like your GGSN is getting overloaded, you have the option of content filtering in Pcrf as well. So once your request comes to Pcrf, Pcrf has the option of opening the packet and seeing that which content and whether I need to block it, whether I need to reroute it, redirect it as well. Charging is usually not done by Pcrf. Charging is done by OCS, but the charging rules can be assigned by the Pcrf. For example, if the charging rule, the rating group is not defined on the GGSN end, so we can define that in Pcrf based on a specific service. The specific rating group is assigned by the Pcrf to the GGSN, and GGSN as it is sent this to the OCS, which actually performs the charging on the Pcrf as well. Okay. Yasser has a question of, right. Okay. Yasin, after I will come back to you. Okay. Just let me finish this part and okay. So control based on usage is something that I already explained. Okay. So let's come back. Okay. content filtering is same like DPI. DPI, Yasser, is the mechanism by which you do content filtering. Okay, DPI is the mechanism. Okay, deep packet inspection, that you have a packet, you open that packet and you deeply inspect it. How you deeply inspect it? You check, okay, what is the source IP address? What is the destination IP address? What is the destination port? Okay, what is the destination URL information? What is the source RAT type? Okay, so all this information and analysis of this is done by deep packet inspection. One of the outcome of DPI is content filtering. For example, you need to block a website or you need to block a specific URL. So once you have done the deep packet inspection, you can do content filtering as well. For example, you can block a website abc.com. Okay, either you have the option that, okay, you can have multiple, because usually a website that is hosted on internet does not have one IP address. It has hundreds of IP addresses. So either you get the IP addresses of those of that website from that website host, but usually if it is a website that needs to be blocked for some reason, usually you don't have all the IP addresses. So what you do is that you perform the URL based filtering. So if that content is coming, that specific content can be blocked. A website abc.com can be blocked, a website XYZ can be blocked. Okay, so information related to that is, okay, no, we inspect the packets of subscribers of not specific subscribers. In DPI, we inspect the packets of all the subscribers. Like if there are 100,000 subscribers, and if 100,000 subscribers are trying to access a website abc.com and I need to block it, so it will inspect the packet of all those 100 subscribers and it will block it. So it's not for specific subscribers, for all the subscribers. Okay, so this is how the content filtering is done. Yes, Wireshark is for inspection, for human inspection. Like I can enable a trace on your number, or I can enable it, or I can take up a trace on a specific interface and I can inspect that. Okay, but that is usually done to troubleshoot that, okay, communication is not being done with an IP address or user cannot browse. This deep packet inspection is usually done automatically in the JGSN, and it has the option of inspecting the packet and then accordingly implementing the specific rule which we have assigned. Okay. The Jafar has a question that if a package of 50 GB, how charging policy and rule is implemented. Jafar, what we do in Pcrf is that I defined a bundle. Okay. I define a bundle. I said, okay, the quota is 50 Gbps. Okay. And the initial throughput that I'm going to assign to you is 2 Mbps. But in that, I have, if you do the configuration of Pcrf, I have the option available that I can do that. Okay, if my 10% quota is exhausted, I can downgrade my speed to 800 kbps. Another 10%, I can degrade it again. Okay, and then I also have this option available that, okay, I have a 50 GB quota available. And based on this, if I'm using this specific service, for example, a streaming service, so my speed is going to be like 2 Mbps. If I'm using browsing service, my speed is going to be 512 kbps. Okay, so all this is available when you create a policy or a rule in the Pcrf. When you define a new rule, you have the option available that which quota to assign, which service to assign, which throughput to which service is to be assigned. Then you have different QCI values. Based on those QCI values and different RG values, you can assign that, okay, which service needs to be charged how much and which service needs to have how much throughput assigned to it. And you can degrade it as well if you if your operator has that option to ensure that there is fair usage policy available, so you can downgrade the service as well. And even to have the option to assign specific times to a package as well. For example, you have a package of 50 GB, and what you're given by the operator is that, okay, in this 50 GB, from like 10 a.m. to 10 p.m., you will get 25 GB with a speed of 2 Mbps, and from 10 p.m. to 10 a.m., you will have a quota of 25 Gbps with a speed of, let's say, 8 Mbps. So this is again, when you configure a rule, you have the option available to create a time-based rule where you can divide your quota into 2 different times, and then you can assign different speeds and different throughput to those specific times. So all this is available in Pcrf, and whenever any request comes to your GGSN is going towards will send your request to Pcrf, and Pcrf is going to send that specific rule that, okay, 25 GB, he has the quota available, you have to assign a speed of 2 Mbps. So GGSN is then acting like a PCEF. It is a policy control enforcer fund. So Pcrf gives the rules and GGSN enforces those rules. So that 2 Mbps is then enforced by the GGSN as well. And if your time is changed, for example, you are using the service after 10 p.m. on each PDP activation request, your request is going to go to your Pcrf, and then Pcrf is going to inform that okay, the user has 25, sufficient quota out of 25 GB left, and during this time he needs to be assigned 8 Mbps. Okay, assigned to user that he is given, say, of all stream browsing is no. This all depends on the rule, the policy which has been created. If the policy is a default policy, that okay, there is a simple, because Pcrf policies are a bit complicated. You have so many options available. Like in a single policy, you can define it based on time. You can differentiate it based on throughput. You can differentiate it based on which service he is using and which throughput he's using. So I'm just giving an example that, okay, if it's a simple rule that, okay, 10 to 10, 25 GB quota and 3 Mbps, and the other 10 to 10, 25 GB quota and 8 Mbps. But even in that 8 Mbps, I have the option available, okay, 10 to 10 for streaming, 8 Mbps for browsing, 1 Mbps quota, quota like 20 G for streaming, 5 G for browsing available as well. Because if you can see that you must have seen in the advertisement as well that different operators say that, okay, you will get a package in which 2 GB WhatsApp is free, or 2 GB for WhatsApp, 2 GB for Facebook. So this is basically how, you can assign it using Pcrf, and as of recently, this can be done in the OCS as well. So the concept is the same. Based on which service you are using, you will be assigned a specific quota, and if to use that specific service, your quota from that service is going to be consumed according to a specific throughput which you have assigned. Okay. If subscriber consume data continuously, then rule will vary. Okay. In Pcrf, what we do is that one is a default policy, and one is for every subscriber there is a default policy as well. Because throughput virtually, I don't think, and there is any operator that has a problem that they have limited throughput. Right now, the available throughput is very high, so we don't block any user from using services if his package has expired. So what we do is that as for every subscriber, for example, we have 20 million subscribers, I will define for every subscriber a default policy. The default policy will be that, okay, default policy is that for user is going to be charged 2 rupees per MB and speed is going to be 512 kbps. Okay. And then on top of that, the priority of the rule, the specific package that I have assigned is going to have a higher priority. And in that priority rule, I can assign that, okay, you pay me 50 rupees, I will give you 50 GB data at a speed of 2 Mbps. So if that 50 GB is consumed in a single month, I have the option of either subscribing that package again. If I don't subscribe that package again, so on Pcrf, I have an option available. Either I block his service, he cannot use the service, or I can downgrade him to the default policy, which is assigned to each and every subscriber. So usually we don't block the service, we just assign them to the default policy, which we have created. And based on that, the user can continue to be served using that default policy. I think all, yeah. All rules are sent, yes, to PCR to PCF only. Basically, from PCR to PCF, the session, the rules are sent, but it's based on the quota. For example, you are assigned a quota of, you have a bundle of 50 GB, and you differentiate and you configure that how much quota is to be assigned in a single PCR request. So, for example, you are allocated a quota of 2 GB, and once that 2 GB quota is finished, then you send a CCR update request to PCRF, and PCRF check if there is sufficient quotas available. It will send all the rules again to the PCEF. So at the start is only if you are not doing any quota, managing any usage or any fair usage from PCRF. But if you have a fair usage policy and that is being controlled from PCRF, so it depends on how much initial quota is allocated by your PCRF, and then your CCR update request and request for another quota, and based on that, the PCRF assigns your new rules. PCRF also assigns quota, and OCS also assigns quota. Nowadays, PCRF is usually not used. OCS has the capability of all the functionality that PCRF is doing. So OCS, the quota that is provided by OCS is with respect to how much it needs to be charged. The quota that is provided by the PCRF is based on the policy or the speed which a user needs to be assigned. Okay, so both OCS provide, because if you look into the the Gui interface traces and the GX interface traces, both the PCRF as well as OCS give you quota, but how the PCEF or the GGSN implements or interprets those quota, that depends on the PCRF gives you. Based on the PCRF quota, there is a throughput that is assigned, and based on the OCS, then the quota provided by OCS is something that that GGSN decide whether to allow the service or not. Okay, location request is from HSS. We observe QC also for specific subscriber. What is the difference between QCI assigned by HSS and PCRF? QCI assigned by HSS is both HSS and PCRF assign QCI. Priority of PCRF, QCI is higher. So HSS is something which provides you a defined QCI, but the QCI that is provided by PCRF has a higher priority. So if it's a different QCI, then the one that is being provided by PCRF will supersede that which is provided by HSS. Okay, some Traditional nodes, you must have listened to me that I mentioned there is a border gateway is another entity that is part of your PS4 network. Functionality of the border gateway is used when you are performing international roaming, outbound roaming or inbound roaming. So your communication towards the other operator, all the communication is done via border gateway. Okay. And charging gateway, I think we have discussed. Charging gateway is basically responsible for collecting the CDRs from SDSN and TGSN. It processes the CDRs and then it is sent to the billing system for validation or maybe charging of the service if required. Yes, HSS is for default bearer and Pcrf is for dedicated bearer. And even if, I mean, if you don't go for 4G as well, even in 2G, 3G, your QCI is, if you need to modify the QCI, we can assign it via Pcrf as well. If OCI disconnected, yes, we can bypass it. We have the configuration available. In that case, then what happens is that you either do not charge the user or then the charging is done based on the GCDRs, which the GGSN processes. So that all depends on how the operator wants to proceed with it. But you have the option of bypassing GGSN as well, bypassing OCS as well. Okay, so before starting the interface, just give me 10 minutes. I need to say prayers and then we will resume. Okay, just let's take a 10-minute break and then we will go towards the interfaces. We can resume with the training. Hopefully everyone is back. Okay. Okay, so the first part, if there are any other queries or concerns, you guys can either message it to me, okay, and then I will add the answers to that in the next session, or I will add it to when we will cover that specific topic. So I will merge your questions with that, okay? So next part is regard to the interfaces, the different interfaces. I will give a little bit of brief overview of the interface, okay? The specific protocols don't need to understand each and every protocol, not because, I mean, in my 12 years of experience, I haven't come across any scenario where I need to dig down into the specific, the lower layer protocols. It is usually the application part, which is more concerned, where we deal with, okay? So the GB interface, as we discussed, this is the interface between your BSC and your SDSN. So the control plane and user plane also we discussed. The control plane is all the signaling communication, your attach requests, your create PDP requests, your routing area update requests, your paging, all this is via the control plane. And user plane is the actual browsing that you are doing. The actual browsing requests, the data uplink and downlink that is done via user plane. So we differentiate between control plane and user plane. In BSC, the specific packet control unit is part of the BSC that is connected with the SDSN over IP. So in control plane, we have the GPRS mobility management and session management protocol that is overlaying the logical link control. So there is a logical link that is created between your BSC and your SDSN. If you go into the configuration part, you will see that you create BSC links. So those links are not actual physical links. Physically, your SDSN is connected to maybe a switch switch to a router to another router, and maybe your IP core is involved, and then you are connected to your PCU. So you connect a logical link between your BSC and your SDSN. The SDSN side defines the IP address of the BSC and its port. The BSC side defines the IP address of the SDSN and its port. And a logical link is created for the signaling as well as user plane communication. Okay, so that is created here in the BSC, and for your user plane, again, it is your radio link control. You have in your SDSN, you have logical link control, and then you have user datagram protocol. On top of that, it is GTPU. So the main protocol from SDSN end that you need to understand or to remember is GTPU. GPRS tunneling protocol user, and GTPC, GPRS tunneling protocol control plane. So from SDSN end or for packet core end, this is the most essential protocol that you need to understand, the layer 1, layer 2 IP, UDP, and then you have GTPU. And even on EGSN end, the communication is on GTPU. Okay. So this is the GB interface. Now we come to the IU interface. IU interface is for your 3G, your RNC communicating with your SDSN. So here in control plane, you have radio access network application part. RANAP is the control plane, and the user plane is the same. It's GTPU. So the lower level protocols are a little bit different, but the application part, the GTPU is the same protocol which is used in your GB interface. This is for ATM, and if you come to IU over IP, if you have the links, your M3 UA links on the IP interface. So in that, the control plane is again, radio access network application part, and in your user plane, you have GTPU. So you need to remember this, that which protocol is running between and the IUPS interface. So it's basically in control plane, it's RANAP, and its user plane, it's GTPU. So all communication is done on these interfaces. Okay, so S1 MME is basically the interface which is equivalent to your GB and IU interface. So in 4G, your E node B is connected with your MME over S1 MME interface. We have some question. Okay, ATM exactly, I don't remember what does ATM stands for, but ATM was used to be used previously when used to have it didn't have IP connectivity. It was connectivity over E1s, I guess. For that connectivity used to be at the transport layer. It used to be ATM. And over IP is then you have your connectivity with your switches and routers and all that. So ATM, I don't think ATM is used anywhere. I believe we migrated in Pakistan, we migrated from ATM to IP in, I believe, 2013. So since then, I don't think it's used specifically in PS core. Okay, Umar has clarified that it's connection oriented. Okay. So and S1 MME, your protocol that on which the communication is done between your E node B and MME, and this is all control plane, because if you remember, I explained to you that in 2G, 3G, and 4G architecture, some portion of SDSN and some portion of GGSN was broken down to make serving gateway. So your control plane communication is handled by your mobility management entity, and your user plane communication is handled by your serving gateway and your PDM gateway. So all your IP assignment and all that is done via MME authentication thing. And once you are using user plane traffic, then you don't need to go to mobility management entity, you directly communicate with serving gateway, which then routes it onto PDN gateway and then towards the internet. So the protocol here is S1 application part. S1 AP is S1 application part. So any communication like your links creation between A node B, MME, if you talk about the MME pool, the weights which MME, the updated weights which MME needs to communicate to E node B, any paging that MME needs to do to E node B, the CS fallbacks scenario in which MME needs to communicate E node B. So all this is done over S1 MME interface using S1 AP protocol. Okay, next is the GR interface. Okay, asynchronous. Great. Thank you, Zubair. Okay, so next is your GR interface. As you remember, GR interface, I asked you to remember it using HLR, the R of the HLR. So GR interface between SDSN and HLR used for authentication and authorization and location update. Okay, so this communication is over the protocol here used is mobile application part. So TCAP is your transport and then your mobile application part. So you can check when you take a trace, you can see that you have mobile application part messages in which you send an authentication request, then you get an authentication response in which you get all your applets and all that. And then when you send the location update, you send the location of the SDSN and then you get an acknowledgement back. So that is all done over mobile application part. Again, we used to have communication over E1. Now it is not used. At that time, it was E1s used to be connected between SDSN and HLR. Now it's all over IP. So it's M3UA. Okay, S6A. S6A interface, as I informed that GR is used for 2G and 3G authentication and authorization. And in 4G, S6A interface is used between MME and HSS. And the significant difference you see is that it runs on diameter interface. So previously it was mobile application part. Now it is running on diameter interface. So you have the same diameter protocol messages in which the communication is done between your MME and HSS. The lower layers are the same L1, L2, L3, SCTP, stream control terminal, and the main thing which you need to remember is that it works on diameter protocol, and it's again control plane. This is all control plane communication. GNGP. GNGP is the interface between your SDSN and your GGSN. Okay, and here your communication, for example, here. This is USN is communicating with USN, or it is communicating with your PGSN or PGW. So this is basically there are two protocols used. One is for control plane, and the other one is for user plane. Here the control plane is mentioned. Okay, so you have layer 1, you have layer 2 or 3, and then the most significant protocol that you need to remember is GTPC and GTPU. For control plane traffic, it is GTPC. For user plane traffic, it's GTPU. So between even MME to SDSN, from SDSN to PGW, from SDSN to SDSN, the interfaces GNGP and even your S5 S5 come afterwards. So GNGP specifically, the protocol which we have is GTPC and GTPU. The messages that are communicated on GTPC and GTPU, once we discuss the call flows, in that at that time I will correlate it that okay, this message is going over which interface. So we will have a little bit of more clarity that okay, which messages are going on GTPC, which messages are going on GR, which messages are going on S6A interface. Okay. S10 interface. This S10 interface is basically between MME and MME. just like I touched a little bit of, we have inter SDSN routing area update. So if we have an inter MME tracking area update, so communication between one MME to another MME, so that for example, a subscriber was located here and being served by this MME, and then the subscriber goes to this location and served by this MME. So this MME will communicate with the older MME over S10 interface to get all the context and all the information. So this is done over S10 interface, and again, the protocol is the same. It's GTPC. S11 interface. S11 interface is the protocol, is the interface between MME and SGW. This protocol, this interface, which is specifically highlighted, and the protocol that is running on this is GTPC, and this is again used when you are creating who have a new attached request. So the communication from E node B goes to MME after authentication. It selects the specific SGW that is on S11 interface. S1 U interface, S1 interface is this specific interface between E node B and serving gateway. This is for user plane communication. So once you have your IP address assigned and you are ready to continue to browse, then your request goes to E node B. From E node B, it goes directly to SGW. So that is then done over GTP U interface, GPRS tunnel protocol user interface. S5 and S8 interface, similar to GN and GP interface. Here it's given a little bit more clarity. Like S5 interface is when you have co-located SGW and PGW. And if you have PGW in a different PLMN in a roaming case, so it's then called S8 interface. So these are the two interfaces which are used between SGW and PGW. And here again, the protocol is the same. It's GTPC for control plane, and it's GTPU for user plane. Okay. And if you want to go a little bit of detail, then it's GTP version 2 for GTPC and GTP version 1 for GTPU. Otherwise, GTPC and I mean these are different versions which have different IEs available to support your 4G communication. GX interface. GX interface is the interface between PGW and Pcrf, if you remember, or between GGSN and Pcrf. Here, the protocol that is running is diameter. If you are aware of diameter protocol, you have credit control request, credit control answer, initial request, update request, reauthorization request. So all those messages. So this communication is done all on diameter. So if you enable a trace on GX interface, you'll see that it's all diameter based communication, which is similar to your GY interface. GA is the interface between your SGSN and GGSN or SGW, PGW, and charging gateway. So GA is the specific interface, and its protocol is GTP dash because it is just for communicating CDRs from UGW or from SGSN to charging gateway. If you enable a trace on G interface, you will see that your CDR, the sequence number of the CDR and its acknowledgement, all this communication is done over GTP dash interface. GY interface is similar to GX interface. Again, it's a diameter based protocol, and all your communication is done on your diameter protocols. We have your credit control request, its answer, we have the reauthorization request and answer and all that. So this is done over GY interface. Okay, so a little bit of functionality. I think we touched the functionality. We'll just go through it again. So mobility management, SGSN MME can control the access of UE to GRA and ETRN and track the location information about you. For example, its tracking area and its routing area. Its functions mainly attach, detach, paging. We will cover all these in the next session, hopefully. Routing area update, service area request, serving RNC relocation, tracking area update for 4G, handover for 4G, and tracking area list management. These are all the basic functionality of your mobility management entity. Okay, another functionality of your SDSN MME is security. I think we discussed security. It performs authentication, identity confidentiality, like it converts your MZ to PTMZ. The NAS signal encryption and integrity protection. This is used in 3G. You have some encryption algorithm and some integrity algorithm which need to be authenticated between you and SDSN. And then you have the identity request authentication as well via EIR. Subscriber data management is implemented in SDSN MME. So once you get the authentication done from HSS or HLR, your subscription information is saved inside SDSN. If you display context, you can see that which APNs are assigned, which QCI information is assigned, which services are allowed, which are not. And then you have a purge function. You can purge the subscriber and you can cancel the location update. Cancel location can also be done from USN towards HSS and towards, like if you delete a user or you remove a user, so it will purge the user information in the HSS, and you can also purge the information in the SDSN as well. From a session management perspective, Pdp Context Management, these are the main procedures: context activation, deactivation, modification, retention. This will be more clarified when we discuss the call flows. The PDP, the basic information contained in a PDP, we'll discuss it afterward, but a little bit of briefly that has the user plane IP addresses, the tunnel identifier, the quality of service, the APN, the RAD type, which radio access terminology, and which sort of service is requested. So all this is contained in your PDP context request and your APN information. Okay, and this is for 4G when you because PDP is a terminology that is used for 2G and 3G. For 4G, the terminology that is used is session management. So in session management, we don't create a PDP, we create a bearer. So there are two types of bearer: default bearer and dedicated bearer. Default bearer is basically, I'll cover this briefly. Default bearer is a bearer that is assigned to you at all times. When you are registered to a 4G network, you are assigned a default bearer. But if you need to use a specific service, like you need to make a call using IMS, or you need to summon some specific service which could not be handled by your default bearer, then a dedicated bearer, a second bearer established between a handset and this specific service, and then your communication is done over your dedicated EPS bearer. So session your network initiated, so you can have network initiated session management and you can have user requested initiated as well. For example, if there's a service someone is calling you, so you can have a network initiated, and if you want to initiate a service request, so you can request it yourself as well. CDRs, I think we have touched. SCDRs, the SMO CDR and SMT CDR, I believe, is for your short message originated. This usually is not used. I mean, I haven't seen. Okay, default and dedicated bearer. Let's go back. Okay, default bearer is basically, we will cover this later on as well. Default bearer is because if you look at the 4G network, in 4G network, you don't have connectivity with MSC. Your handset is connected just with the PS4 mobility management entity. So once you send an attached request, I mean, you turn your mobile SIM on, it will create a bearer between your SDSN and your handset. Okay, so that is it. Default bearer, which has a specific QCI assigned to it, and that is basically used for your basic default services like browsing, streaming, and all that. dedicated bearer is created when you need to use a service which is not supported by your default EPS bearer. So, for example, you have your IMS call. So IMS has a specific QCI which is not covered in your default EPS. So for that, whenever you need to initiate a call, a voice call, using the IMS or using the voice over LTE service, so you need to initiate a dedicated EPS bearer which has the specific QCI assigned, which will then allow you to make that voice over LTE call. So default bearer, so dedicated bearer is established specifically for a service, and then it gets deactivated once your service is used. Default bearer is something that is assigned to you at all times. And once you detach your handset, only then your default EPS bearer gets deactivated. Other than that, you have a default EPS bearer established for each and every service that you need to use whenever you are attached to the 4G network. Okay, EPS bearer is the PDP context. Actually, PDP is a terminology that is used in 2G and 3G. And bearer is the terminology that is used in 4G. So EPS bearer is similar to your PDP context, yes. Your PDP context is in 2G and 3G, and your EPS bearer is basically the context that we call in 4G, right? So EPS bearer is in 4G, and PDP context is a terminology that is used in 2G and 3G. Yes, EPS bearer is only for 4G. When you're using 2G, 3G, the terminology we use is PDP context. So you see that, okay, PDP context is established or not on GGS and SGSN. But when you use 4G, the terminology used is bearer, whether it has a bearer established or not. Same information, yeah, it has same information and some additional information like it has APN. RAC and LAC, no, it doesn't have, because in 4G we use TAC, tracking area code. Okay, so we have APN, we have TAC. What I will do is that I will record one PDP session and one bearer information of my number, and in the next training session, he will see that which information do we have in a PDP context and which information do we have when we establish a bearer. So you will have more clarity. Okay, so like which information is shared over there. Okay, so Cdi management, yes, we touched. Main is this one. We have the SGSN over Gui interface and GGSN over GS. So main is SCDR and GCDR. Short message service, I think we can skip this part. Short message service, I don't remember it being used in 2G, 3G. Yes, in 4G we use. In 2G, 3G, we don't use SMS service or SGSN, and I think this is very relevant. You need to enable some switches, you need to enable some licenses, and then basically your handset sends a request to RNC, from RNC it goes to SGSN, because usually your SMS flow is node B to RNC to MSC and then to SMSC. But if you need to use SMS over SGSN, then you need to enable that switch, and then your message is going to go from your handset to your node B RNC. From RNC, it determines that, okay, it needs to be sent over SGSN, and then SGSN connects to your short message service and receive as well. But usually it's in 2G, 3G, it's done via MSC, and in 4G, yes, it is done over packet code. Okay, so as I discussed that in 4G, there is no eNode B does not have any interface with your MSC. In 3G, your RNC is connected with your MSC or IUCS interface, and even in 2G as well, your BSC is connected with your MSC for voice service. So in 4G, we have two options available. The ones we have heard. The first one is CS fallback. In layman term, what happens is that when you need to initiate a call, you fall back to either 3G or 2G, and then you initiate your call because your BSC and RNC has a communication with the MSC, and then you initiate your call. You complete your call. Once your call is completed, you fall back again to eNode B. The other is SRVCC, single radio voice call continuity. This is done when if you have an IMS service that is available with you. Okay, so in 4G, what happens is that once you need to once you perform your location update title, which we will see in the call flows as well. So you send a combined location update. So that location is updated in the MME as well as MSC as well. So there is this interface called Sds Interface. So once you get an attached request in MME, you send your location area information and your IMSI information to MSC as well. So MSC has the information that okay, which MME is serving this specific user, so that if there is an incoming call, so MSC can page to the specific MME. MME can ask the specific user to fall back to 2G and 3G, and based on that, the MSC can establish the call towards that user from 2G and 3G. So one solution is CS fallback. The other one is single radio voice call continuity. SRVCC is okay. Send SMS by GS to MSC instead of direct sending to SMSC. No, MSC controls the fallback when there is an incoming call. For example, I am connected to 4G and someone calls me. So then my request, the paging request comes from MSC to SDSN, and then SDSN informs me to call back. Okay. For originating call, it is the MME's responsibility. We will have a session on that as well. And your handset needs to originate a call. It sends a request to your MME, then MME asks your eNode B to call back the user to specific RNC, specific node B or BTS. User calls back, and that is how your originating call is established. For terminating call, yes, MSC pages your MME, and your MME is responsible for basically making the user call back. Okay, so if you have IMS installed in your network, so in that case, your PGW has a communication available with your IMS. In that case, you don't need to call back to 2G or 3G if you have IMS available. I think SRVCC, let me just check. I think IMS is not covered here. This is during call, yes. Let me just check. Yes, I'm good. Yes, I think Haitham is right. SRVCC is for originating call over SP interface. It's not IMS. Okay, I'll cover this part in the next training session. Okay, the SRVCC and the because I forgot to add the IMS part as well. So I'll cover that with IMS as well. The quality of service mechanism. This is a bit advanced topic. We will cover it once we will go in deep discussing how your quality of service is maintained. Okay. Roaming control. Okay. Roaming control is afterward. Okay. So this is the last topic that we'll be discussing is your UE states. This is something that usually when we check the profile of a user. Okay. So in GPRS, there are 3 states that a user is in at a time. User can be in ready state, can be in the idle state, and can be in the standby state. Okay. So if, in easy terms, when a user is detached from a GPRS network, he goes into an idle state. And when user is attached, you perform a location update, you come into the ready state. Okay. And then we have some timers defined in the SDSN that if you are not communicating, you're not browsing for a specific amount of time, which is called the ready timer expiry, you go into the standby state. Okay. And in standby state, you are still connected to the SDSN and you can perform your PDU transmission. So once you start browsing, you can go into the ready state again. And if you detach, you turn your mobile services off, you get GPRS detached. Okay, so MS in idle state is not attached to the network. No context of MS is set up, and the network does not know location of the MS. So once you are in the idle state, you can move from one location to another location. The SDSN will not know what is your location until unless you perform GPRS attached. In standby state, MS is attached, and the context has been set up. The location of MS is only indicated by its routing area. So once you move from one routing area to another routing area, you will send a routing area update, and SDSN will know that what is your location. MS in the standby state can be paged but cannot send or receive data. Okay, so once you are in standby state, you can receive a paging information, and based on paging information, you go into the ready state, and then you can have send or receive data information. In ready state, the MS is attached to the network, its context is maintained, its location is maintained to a specific cell. If you check the context of an MS IGN, you can even check this cell information, which cell you are attached to. That information is contained in its content in the ready state. Can receive and send data. Obviously, in this GPRS paging is not ruled out because you are already connected in ready state, so there is no need for any paging to be done. Okay, for other services can be used to deliver paging request, but specifically for PS paging in ready state, there is no requirement of that. That's required when you are in standby state. Okay. Yes, MM is mobility management. Okay. So next is your UE state in 3G network. Okay, the UMTS. So the terminologies are a little bit changed. The meaning is the same. So it's PMM detached, PMM idle, and PMM connected. Okay. So once you are detached, you are not connected with the network, you are in the PMM detached state. Okay. And the standby state in 2G, what we call the standby state, in 3G, we call it the PMM idle state. So it is a time when you have PS connection, you don't have a signaling available, so you go into PMM idle state. That is depending on the timers which are defined in your SDSN. A specific time has passed and you are not browsing, so it takes you from PMM connected to PMM idle state. And the third one is PMM connected state, in which you are performing active browsing. Okay, so in PMM detached state, MS is not attached to network, no mobility management context, or the MS is set up, and the network does not know the location. So in your PMM detached state, if you move from one location to another location, the SDSN will not know what is your location because it does not have any information available. In PMM idle, is attached to the network and mobility management context is set up. Okay, the location is only indicated by routing area ID. Okay, so it is similar to your standby state, that its location is only available to routing area ID. In MM idle state, can be paged but cannot send or receive data. Paging is done. And based on that, your PS connection is established, and then you go to PMM connected state. And PMM connected state is just like ready state over here. All the information is attached to the network. The MM is set up. Location is indicated by the service area identifier. Service is similar to your LID. In 3G, you have your service area identifiers. Okay, and connected state can send or receive data, and PS paging obviously is not involved because you are in active or connected state, so there's no need to page. Okay, so in EPC, in 4G, there are two types of states. One is related to your mobility management, one is related to your connection management. Okay, so your state management basically to ensure correct handling of operation. EMM is mobility management, ECM is your connection management. So EMM is implemented through attach and tracking area update, and ECM ensures the connectivity of signaling between UE and core node. Okay, so for your signaling to track the mobility of a user, there are two states, and to track whether the connection is active or not and user can browse or not, we have connection management. So we'll see what this is. So EMM, we have two states. One is deregistered state and one is registered state. So when do you go into deregistered state? When you are detached. When you have your attach request gets rejected due to some reason, your tracking area update gets rejected to some reason, and all of your bearers, your default as well as your dedicated bearer, all of these have been deactivated, and that time you are deregistered. And once you initiate an attach request and your attach gets accepted, or you send a tracking area update request, it gets accepted, or you move from 2G, 3G to 4G, you immediately go into EMM registered state. So deregistered UE is unreachable for MME because valid location and routing information is not contained in EMM context. Partial context can be retained in UE and MME, but you say the authentication and key agreement is not required every time. Okay, so even when you go into EMM deregistered state, your context is maintained by TSDSN. So once you send another attach or tracking area update request, it is not necessary that you have to get authentication done from HSS each and every time. In EMM register state, after successful attach or inter-right tracking area update procedure, the UE switches to this state. In this state, MME knows the precise location of UE, and obviously in this state, the user can, whenever user perform tracking area or routing area update, its location is known. ECM has two states, the ECM idle and ECM connected state. In ECM idle state is when your S1 connection is released, and when you establish the connection again, you go back to ECM connected state. So UE is in an idle state when there's no NAS signaling connection between you and network, and this eNodeB does not have the context of UE, and UE does not have any active S1 MME or S1 U connection. Okay, so in order to have a connection, you need to establish the S1 connection, and then you go into ECM connected state. And in ECM connected state, there is a NAS connection. eNodeB has the information, and ECM connected is basically when you are performing active browsing. So all your information is available in eNodeB, and it's available at the UE level and SDSN level as well. Okay, so I think we can cover this mobile address allocation as well. I think somebody was asking this thing that, okay, how is an IP address allocated? If you remember, I told you that PS is all about IP to IP communication. Okay, so your URL is different, websites have IPs available. Your handset needs to be assigned an IP address, but how is that IP address assigned? One is via GGS and address pools. Like I said, that you take an APN, an access point name, and that access point name is resolved by the GGSN into an IP address. So there are multiple IP pools which we configure, and we assign them to specific APN. So that if I'm bringing an APN of WAP, I am assigned a specific IP address. If I'm bringing an APN of internet, I'm given a specific IP address. If I'm bringing an APN of IMS, I'm given a specific set of IP address, which is then as GGSN has the rules available to basically route the traffic. The other way that I can do is by assigning a static IP address. There are some subscribers, there are some applications that require that, okay, their handset IP should not change. They have their own machines, they have their own communication in which they want that their IP address should not be changed. So So such corporate customers approach an operator and inform them that, okay, this is the list of handsets and this is the IP address which we require. So please assign this specific IP address so that our IP address, even if a session gets disconnected and connected again, we are assigned the same IP address. In GGSN pool address, it's dynamic allocation. At one time, you're going to be assigned a different IP address. Another time, I'm going to be assigned another IP address. So it's not a static specific IP address. In HLR, the IP address that you're assigned is a static IP address, and that same IP address is then assigned in the address pool as well. Okay, so HLR is used for this as well. The third functionality is a radius and a DHCP server. In early days, we used to have radius server and DHCP servers. We used to send a request to a AAA server and a DHCP server and then ask them to perform to assign an IP address. But right now, this function is done by GGSN right now. So right now, we just have two IP address allocation methodology. One is just static IP address assigned by the HLR, and a dynamic IP address, which is assigned from GGSN address pools. Okay. Yes, ready timer is configured on MME. Yes. Yes, in idle state, there is no RRC connection, but there is info. Yes, RRC connection is the radio link control between MME. No, idle state is not in MME. I think you need to ask in SDSN, right? Ali? Because idle state is for 2G and 3G. That is in SDSN. Okay. So if we answer this with respect to SDSN, yes, there is no RRC, there is no connection, but the information is maintained in that. And are you talking about 2G or are you talking about 3G? Because 2G idle is different and 3G idle is different. So you're talking about idle or are you talking about PMM idle? Let's go back. This is something that confuses. So in 2G, the idle user is not attached. So there is no context of MS, okay, in the MS or in the SDSN. So you are detached, so you don't have any information available in SDSN in idle. If you're talking about PMM idle means your connection is not established, but your information, your context is retained inside the SDSN. Okay, so you must have heard of a flow service request, because in 3G there is a concept of radio access bearer. So once you are not using a service, so there is no need for you to consume a radio access bearer. So what happens is that after a specific time, when you are not using the service, your radio access bearer gets disconnected. So your PSN connection is released. Okay, so your context remains in the SDSN, but your connection is released because there are specific limited amount of errors that are available in your keynote B end. So any other user that needs to use the PS services, the radio bearer established is assigned to that specific user. If you need to use the PS services, you establish your radio access bearer again by sending a service request. You send a service request, based on that, your connection is established. Okay, and then based on that, you get okay. Okay, 4G. Okay. Okay, 4G I'll answer. And yes, Halima, you can go for prayer. I think the contents that we need to discuss today are completed. So I'll just go to if any questions are unanswered. And the quota for today, the topics for today, I think we have covered. I think I took a little bit of extra time, but this was the first session. Hopefully, the next one won't be much long. Okay, fine. So I think everyone, thank you very much for participating in this. I hope you got to learn something, and inshallah, we'll see when we can have the next session. We can plan it on next Saturday. Hopefully, I will let you know accordingly. Okay. The recording, yes, will be available. I'll need to see how do I share the recording and all that. The training slides, yes, I can share with you. And inshallah, we'll see. And if there is anything that you found out that I need to improve or something like that, or any topics that you need to be added on, we can add that. Okay. The material I will share this on the group. The training session I'll see how can we do this. Okay. And from next time, I think we have some experts available. So what we will do is that next time I will open the communication, and then we can have an open session as well. I believe there are some experts here as well. I see Hatham has given some good input. Yasir has given some good input. So we can have an open session as well. And I'm not a very expert. So where I'm wrong, I expect others to correct me. And we will just have a good training session. Okay. Next session, hopefully next Saturday. I will confirm it in 2-3 days. Okay. Yasir, mera bhaiya, yes, we will have it, but this is in future, okay? We will go with the basics. There are some people who need to learn the basics first, okay? So we will just go one-on-one. This training session will continue. I will try to, my aim is to inculcate as much information that I have. I don't want to withhold anything. So anything that I have, I'd like to share with all of you. So we will continue this, and when the time is right, we will do the troubleshooting, Wireshark, PS Toolkit, everything. Okay. So thank you very much. Have a nice weekend, everyone, and see you soon. Allah Hafiz.
Thank you so much. Thank you. I'm trying to write something but fail. But